one of my biggest frustrations in my career in crypto is like people build these really cool systems that have kind of all these like nice theoretical properties, but they don't get them to market, and they don't like iterate because they don't have people actually giving them feedback, and they don't have tight feedback cycles, and like there's no product feedback. And so it's like still important to just like ship as fast, like ship as often as possible, and actually like get stuff into the hands of people, whether it's through like bounties programs or hackathon prizes. I know Superfluid is also kind of a similar mindset, that like that's a great way in this kind of like early and emerging like developer ecosystem to get tighter feedback loops. I think that's been really productive for us.
Hello and welcome to another episode of Devs Do Something. Today's guest is Yorke Rhodes, founding engineer at Hyperlane, a protocol which serves as a platform for building cross-chain applications. Yorke is very knowledgeable about building smart contracts. He was previously at Celo and has spent his career going deep on Solidity before joining Hyperlane, which is previously known as Abacus, as a founding engineer. In this episode, Yorke and I talk through the details of Hyperlane's system for sending and receiving messages cross-chain, and we talk through cross-chain tech more broadly. We also talk through things like how Hyperlane thinks through developer experience and building APIs. I, as someone who works in DevRel, think they have pretty good docs, and it was interesting to talk with them about that. And we also go into things like Yorke's thoughts on smart contract security, and we wrap the episode up by asking Yorke what some of his favorite design patterns and optimizations are, which is something we always love asking for the sake of the learning of you listeners out there. So if you're a Solidity developer with an interest in anything related to cross-chain stuff, I think you're going to love this episode, and this is really for you. So I hope you enjoy. Are you a DAO or crypto-native business with salaried employees? Or do you perhaps work for one? If so, whether you're a team of 5 or 500, your organization can save time and money by streaming salaries with Superfluid, who also happens to be the beloved producer of this podcast. With salary streaming, your management team no longer has to worry about executing multi-sig operations every month or manually executing hundreds of separate transactions to pay their team. Contributors and employees, on the other hand, get paid by the second, which, to be honest with you, is a pretty killer benefit on the receiving end. Those of us getting paid via stream can connect our wallet to the Superfluid dashboard and see our balances ticking up in real time. It's kind of mesmerizing and feels like you're being jacked 10 years in the future. When you're paid in a stream, it flows in perpetuity until your team needs to adjust compensation, which effectively puts Web3 payroll on autopilot. Salary streaming is easy to set up thanks to our recent integration with CoinShift, the leading crypto treasury management platform. In just a few clicks, you can securely set up payroll for hundreds of employees in just a single transaction, all from CoinShift's dashboard. If this sounds like something you're interested in exploring, you should visit superfluid.finance/payroll and book a salary streaming demo today. Thanks to all of our sponsors. Let's get on to the episode. We are here today with Yorke from Hyperlane. Welcome, man.
Thanks for having me, Sam.
Yeah. No, it's good to be here chatting with you. We met last week. Bogota and DevCon were last week. We met at an event there. Got to talking about Hyperlane and some of your work in the space, and thought you'd be a fantastic guest. So, before we get into some of the things around Hyperlane, cross-chain messaging, and just smart contract development stuff more broadly, I'd love to just understand what your background is and how you got involved in crypto.
Definitely. Yeah, I'd love to share. So I guess my intro to crypto was actually a little nefarious. My high school robotics team somehow got involved in trying to mine Bitcoin on our school's computers. And that was kind of not an initiative that I was totally responsible for, but that was kind of my first exposure. And then I think word somehow got around to the consensus folks who were local. I grew up in New York City and went to high school here. and they came to one of our hackathons and like kind of did, my school was like fairly STEM focused, kind of technically focused. And they wanted to have a presence at our hackathon, and basically we're like offering a bunch of internships. And so, yeah, I made the jump after my senior year of high school and was working on kind of some really early days stuff, like very naive prototype level stuff. It's kind of funny to reflect on. Like, I worked on this project called Proof of Physical Address, which now seems, pretty silly in hindsight. But yeah, it was like an automated snail mail system where you could basically like receive a secret in the mail and like prove that you control that mailing address, and then submit it to the registry on chain. And like, that was the idea we had at the time, is like that would maybe function as some sort of KYC mechanism in future. Now maybe we're coming full circle with the like on-chain KYC stuff in the last couple months with some of the OFAC stuff. But yeah, worked on some stuff like that. Token curated registries, if you've heard of that concept, that's another like dinosaur that not many people have heard of. And just like some early voting systems. That's what I was excited about at the time.
I love the background. It's cool you've been a tinkerer for a little while, and it's cool that some of your ideas are coming full circle, even if some of the identity things are a bit controversial at this point. So you ended up working at Abacus, which became Hyperlane, right? I'm correct on the rebranding there,
yes,
right? You guys were once Abacus?
Accurate.
Okay. Nice. So I would love, just for our listeners, before we really dive into some of the specifics, can you give us an overview on what Hyperlane is?
Yeah, definitely. So Hyperlane is a developer platform for introducing cross-chain composability to smart contracts. And this is kind of an interesting problem space because, especially in an era of kind of all of these competitive scaling solutions, there's a lot of fragmentation with respect to network effects of applications. So applications, when they deploy on these new scaling solutions, because they're trying to provide maybe a better user experience for their users, that's like a lower fee environment or a faster finality, settlement time, they tend to do these deployments in kind of a way which isn't interoperable and is actually like sometimes like what we call vampiric to their existing network that might exist on some other chain, because they're deploying new liquidity incentives to kind of bootstrap the network on this new chain. And those liquidity pools, for example, like if we take the Uniswap case, right, they're actually kind of individual silos that kind of the LPs move between just to chase incentives. So Hyperlane is built to kind of try and introduce a developer primitive to solve some of this fragmentation problem. I think most people are familiar with the concept of asset bridging and in the cross-chain kind of category of applications. But Hyperlane is what we call, is like a generalization of asset bridging. So it's what we call like an arbitrary message bridge, or like a generalized message passing protocol that allows any information that exists in a smart contract to be moved between chains in a way that's like crypto economically secure. So asset bridging is moving ownership information between chains. And this is kind of like a generalization of that, mostly because what we've again observed is like with asset bridging solutions, you also have this fragmentation problem of each bridge or each network or each path that an asset takes actually like introducing an additional like synthetic derivative that has its own set of like fragmentation problems. So it's kind of the next iteration of interoperability. I saw right before I hopped on with Sam here that you've had a couple of folks talk about cross-chain architectures already on the podcast, which is awesome. Like definitely, I think we're all on the same team with respect to just like kind of bringing awareness to this emerging category of application design and architecture. And yeah, that's basically the gist of it. I do want to mention, I guess, that there are kind of benefits to cross-chain architectures for applications beyond just like introducing composability of like applications. Like you could imagine different sides of like an n-sided marketplace might care about different underlying properties of the blockchain that their assets are on. So like classic two-sided marketplace in crypto is like lending markets, borrowers and lenders maybe have, you know, fairly different constraints on what they want their user experience to look like, or like what security properties they care about, et cetera. And so like that could also be something that Hyperlane is useful for, is kind of enabling both of those parties to have the optimal user experience without fragmenting the network. And so, yeah, that's kind of like the high level overview.
Nice. Yeah, that's very interesting. And I guess, wait a second, I want to get into how the actual messaging works in Hyperlane's case, but can you elaborate on what you just said there at the end, where you'd have an n-sided marketplace that could potentially use Hyperlane to improve the UX? Are you saying that you'd have a marketplace where like lenders are on one chain and borrowers are on another chain, and you'd have just interoperability between both chains? Or is that what you were saying?
Yeah,
or am I misunderstanding?
Yeah, exactly. So that's just like an example of what we call an interchain application, which, yeah, you could build, you know, Compound or Aave in kind of like a natively cross-chain way, and then have basically the ability to borrow against, you know, remote collateral, just as an example. Now, there are a bunch of kind of additional constraints or like additional complexity that's introduced when you start thinking about these sorts of cross-chain or interchain application architectures. I know you wanted to get into a little bit the implications on smart contract security, but in the case of lending markets, one property that you lose when you introduce asynchrony is you can't have flash loans. And so because flash loans rely on atomicity, and so the implication is basically kind of lending markets for long tail assets can't be as capital efficient because you require liquidators to have exposure to the underlying capital, rather than anyone being able to operate like a liquidation bot without basically doing market making. I mean, again, this is like getting in the weeds a little bit, but yeah, there's these kind of emergent application architectures that benefit potentially from being cross-chain natively. That's kind of our thesis, that most of the existing applications that have reached some level of traction or like PMF in a single chain context have an extension or a kind of reimagining in a multi-chain, in a natively multi-chain architecture that kind of can improve certain like downstream user effects. And that, yeah, was just one example I wanted to illustrate.
Yeah, that's interesting. Yeah, I think our world could get really cool if different environments weren't as siloed as they are today. And that's part of the energy behind the cross-chain, I guess, movement, right? It's trying to, you know, take all of this liquidity we have, and it you know, even if you just take like the EVM, right? Every EVM compatible chain, like if it was easily able to be connected with if every chain was able to be connected with every other chain, even in our ecosystem, you open up a lot of really cool things where, you know, you don't have to worry about, you know, is my app deployed on every single environment, right? You could just make use of cross-chain technology to solve some of these problems instead of thinking of every individual chain as its own city, right? It is easier said than done, though, like you said. And I think with that, it might be interesting to talk through how exactly message passing is working with Hyperlane, right? I think you guys have I don't know if you call them validators or relayers. I know that the terms are sometimes used interchangeably when it comes to cross-chain stuff. But how, like, let's say that I want to send a message from Polygon to Avalanche using Hyperlane. What's this look like, right? People can go to your docs and see a little bit, but I'd love the end-to-end explanation from you if we can.
Yeah, of course. So I guess just to preface, a lot of the decisions the design decisions made in our protocol, which might be unfamiliar or to those like kind of who have been thinking about these sorts of cross-chain architectures, are all motivated by the simplest possible developer experience for application developers. Because like you said, like our world could get really cool if all these things were composable, but it's also pretty high complexity and fairly intimidating, especially for like some of the folks we've been kind of testing and prototyping with at hackathons. And so a lot of these decisions that we make in the protocol design are for developer experience, and then ultimately for what we think will be the best user experience that the applications kind of pass on to their users who are building in this new kind of multi-chain paradigm. So you noted validators and relayers. In our system, those are actually distinct roles. And I can kind of just dig into the life cycle of sending a cross-chain message, I guess, as a developer, and then maybe talk about what the implications for the user are, and then what the, I guess, roles are that are maybe kind of intermediaries or parties that you need to understand, and what the trust assumptions are. So life cycle of a simple message. There is a on-chain smart contracts API that Hyperlane exposes that allows you to specify a destination chain and a destination address on that chain, and basically arbitrary bytes. So the interface looks like any other smart contract function, and that's, we expose it on chain because we want this to be ultimately composable with smart contracts and not just kind of like client layers. And we're kind of like composability maximalists, I guess. But the interface looks like that. And so when you call that function on the Hyperlane contract on each chain, or on, let's say, Ethereum mainnet, you call the dispatch function with those three arguments. What happens is your message content gets committed to by an incremental Merkle tree. This is a pretty kind of standard pattern for, I guess, storing a commitment to the history of information without storing all of the information in history. And so, you basically get your message committed to by an incremental Merkle tree. And we have a protocol which is designed to move that message eventually to the destination chain and perform whatever action your message encodes. So, like I mentioned earlier, there's two roles in our system. There's validators and relayers. The validators are staking on the source chain that you're sending a message from. We haven't defined, I guess, all of the kind of economic constraints of the staking protocol. Right now, we're using a permissioned set, but we're hoping to kind of make that as permissionless of a role as possible for anyone to participate in. But basically, validators are staking on the source chain, and as messages are being committed to the incremental Merkle tree, these validators are producing a signature on the root of that tree. And they're making that signature available to the public. So they have kind of a very simple responsibility. The validators are not actually performing consensus with each other. So that's maybe why the term validator is maybe slightly co-opted here. But when we say validator, we just mean someone who's performing a staking role and who needs to be, performing some function to receive rewards for performing that staking role. So they need to be producing signatures on the Merkle root and making those available. Then the second role in our system is the relayer. And the relayer is basically responsible for observing the message that was dispatched by the person who called the Hyperlane API, observing the message content, because again, that's not available in storage on chain. They need to have basically observed that in like event log. And in addition to observing that message content, they're observing these signatures that validators are producing. And their responsibility is to bring both of those pieces of information to the destination chain. On the destination chain, we have a function which anyone can call. So the relayer is a permissionless role that anyone can operate. And the relayer provides to this function on the destination chain the set of signatures from validators on the source chain, which commit to a Merkle root that commits to a specific message content, as well as the relayer providing the message content itself to the function. And what that function does is it verifies that basically there's like a crypto economic quorum of security associated, basically that there's a quorum of validators who have signed a specific Merkle root. So it does some signature verification. And if a quorum has been reached, it allows the message to basically be passed along to the recipient address that was specified in the original invocation on the source chain. And so you'll notice in this, so that's basically the kind of protocol lifecycle. If you think about like just one layer out of the onion of like what's going on with the application, there's kind of like, so let's say in the case where we have, this cross-chain composability where there's an application on chain A and a different application on chain B. Application A wants to call a function on application B, or whatever, on chain B, and they call dispatch with that other application's address and that blockchain identifier and what function to call. And again, the validators, so that message gets committed to by this incremental Merkle tree. Validators on chain A produce signatures on that Merkle root. Those signatures are made available. Relayers bring that message content along with those signatures to the destination chain. A quorum of signatures is verified, and once that condition is satisfied, the function can be called. And so what this means is the application on chain B needs to do some amount of access control such that only like the Hyperlane system can call this function if it's permissioned to like be a specifically cross-chain action. But yeah, generally this like is the kind of end-to-end life cycle of like what a message looks like. Now, just to, I guess, dig in a little bit deeper, the the reason we're using this kind of like model where the validators are staking on the source chain, and we're using this like incremental Merkle tree and a signature verification with the Merkle root on the destination chain, is because our system is designed for economic security with low latency. And so what that means is we can't prevent validators from producing signatures and giving them to relayers kind of off-chain. We can't prevent them from producing signatures which don't commit to a specific message that was actually dispatched on the source chain and is committed to by the source chain's smart contract state. We can't prevent that. And in general, almost any of these cross-chain systems can't prevent kind of like a set of actors from colluding and doing something malicious, or basically like performing fraud for some kind of like exogenous reason. There's some exogenous incentive that they want to exploit. And so we can't prevent them from producing those signatures and like trying to process a message on the destination chain, which wasn't actually dispatched on the source chain. However, what we can do is guarantee on the source chain that someone can always provide a fraud proof which shows that validators signed something which isn't committed to by the storage on that chain and the incremental Merkle tree on that chain, and verify that fraud proof in smart contracts and slash the validator. So the beauty of our system is there's no specific dispute window. So actually a fraud proof can be submitted in perpetuity, so long as the validator is basically still part of the staking set.
Interesting.
So again, the high level idea is like, instead of preventing fraud, kind of like, there's in optimistic models, the idea is like you introduce a fraud window and you allow kind of any of these like these watcher roles to dispute the content of some message that like is trying to be processed on the destination chain, but like maybe wasn't actually dispatched on the source chain. The problem with that is you introduce basically a lower bound on the latency of any of these applications. And you also open up your system to denial of service vectors, because basically if a watcher has some exogenous incentive to do so, they can basically pause your system and prevent it from processing any messages by continuing to dispute results during the fraud window. There's not a good incentive scheme that I'm aware of that reconciles the problem of like watchers basically being a denial of service vector and simultaneously having them kind of like perform their duty to be monitoring all of the messages during like any given time window. So like I think in the systems that I'm aware of and how they operate, watchers are a permissioned set of actors, because otherwise any rogue actor could basically perform a denial of service attack on the protocol. And so they need to be a permissioned set to prevent that. But then the problem is, if that permissioned set, which is probably operated by some like centralized party. Oh, can you still hear me? Yeah, if that permission set is operated by some centralized party, we've seen in practice that it's not a guarantee that like they'll be able to prevent all possible operational like failure modes. So yeah, there's like kind of some nuances to the optimistic model in terms of like how the incentive structure works that I think we identified as trade-offs, right? But that introduce a lower bound on latency for these cross-chain interactions that ultimately we think doesn't translate well to a good end user experience. So if you have, like, even if you can get the fraud window down to, let's say, 5 minutes, which is far lower than what most of these systems are using in practice, that still doesn't translate well to, point of sale type experiences for users. Because you want that experience to look like less than 5 seconds, right? So ultimately, like I said, our protocol is designed for these low latency economic security use cases where we can support point of sale or kind of like more trading type use cases that are more sensitive to latency. And we can't prevent fraud in all cases, but what we can do is guarantee an economic cost to fraud. And so if that economic cost exceeds the potential value gain from this person committing fraud, then we have a nice kind of like economically secure system, right?
Yep. Quick question for you. How does this feed into the sovereign consensus model you guys have? Are you basically just describing what sovereign consensus is, or is there more to that?
No, so that's actually kind of a layer on top of this system. So I'm more than happy to get into that if we're ready to go there.
Yeah, please do. I think so. In terms of that, right? So you have this system, right? Anyone can submit a fraud proof, right? I'm assuming in this case, if it proves that there actually was fraud, the validators are slashed on the source chain. But what is sovereign consensus, right? You see that in several places in your docs. There are mentions to it. I read a little bit about it, but I would love to understand how that fits into the rest of this, right? Because, and the reason why I ask, and the reason why I push on this one is that I think with a lot of the cross-chain systems, the interesting technical concepts and the real differentiators here are in the way that you secure the system, right? Cross-chain bridges and messaging has been probably like the biggest surface area for hacks in the last, 12 months. So we'd love to understand just the full picture and what sovereign consensus is, if you don't mind explaining it.
Of course. Yeah, would love to. So just like super quickly, just want to like elaborate a tiny bit on the fraud proof system. So
Sure.
Something that we're really proud of is that in addition to having fraud proofs for kind of like invalid messages that validators have attempted to get processed on the destination chain, we also have what we call like a censorship resistant fraud proof, which basically means that because of the properties of like, we kind of exploit some of the properties of the incremental Merkle tree. And basically validators can either choose to process no messages or all messages. They can't choose to censor individual messages, which is another kind of really important property we think to the best solution to these cross-chain protocols, because as we've seen recently, there's kind of a lot of fear and disillusionment around what kind of like nation states and centralized actors can do to come in and censor certain protocol activity. So yeah, just wanted to highlight that. But yeah, let me jump into sovereign consensus. So what I've described thus far is kind of the default security mode of our protocol. We think it makes sense as kind of like for the majority of application use cases, we think that economic security model is sufficient for people to operate without a lot of, I guess, fear that there's going to be some catastrophic failure. However, you highlighted that there's been, an insane amount of attention on these security models because of how many high value hacks there have been. And, we totally recognize that different applications and different protocols want to make different trade-offs. And there's kind of like a vibrant competitive landscape of like security models in these cross-chain systems, which is really exciting, right? Especially with some of the like zero knowledge technology that's coming out. I don't think any of us want to limit the competition there. And we want to allow people to opt into the model that they trust for their specific use case. And so what sovereign consensus is basically a part of a version 2 of our protocol that we're actively getting out the door right now, which is basically a modular design for cross-chain security that allows applications, specifically recipient applications of cross-chain messages, to specify additional security constraints on top of what our default operating mode is, which are conditional on the message content. And the reason why this is interesting is the economic security model that I described, has this constraint that as long as the value to be gained from a specific message is less than the cost to commit fraud for validators, we have a nice, like, economically secure protocol. But what if it's difficult to measure that? Or what if we want to process a message which has some like abstract notion of economic value, like maybe it's cross-chain governance, or maybe it's these sorts of things that you can't just like associate with a specific economic cost. You want to allow applications to opt into additional security constraints and trade off whatever properties they care about for their specific use case. So, we have our own opinion about what the what we think people should kind of default into, which is this like low latency economic security model. But really, like if you're doing cross-chain governance, for example, which is less latency sensitive of a use case and has this kind of like abstract economic value, you might want to allow the DAO that's doing this cross-chain action to opt into additional security constraints on cross-chain governance actions, which don't necessarily trade off like security for latency or cost for latency, right? And so you could introduce an optimistic security model on top of the economic security model, or in place of, or you could just require like a multi-sig of operators to also provide signatures beyond the Hyperlane validator set. And this allows you to basically, if an application maybe reaches the scale where that's relevant, like you could look at a USDC type asset issuer, right? Like that's maybe there's actions that are sending value between chains that maybe exceeds the value of the Hyperlane like economic security. Circle as the asset issuer could operate their own optimistic security model, or just even their own like multi-sig, which is kind of how their system operates today, and opt into that model while still benefiting from kind of our protocol being a composable smart contract API that is like available and has these guarantees around kind of like latency and delivery and all these things, such that applications don't have to operate this like end-to-end system. They can just like pick and choose which things they want to opt into and really customize the security constraints. And what we've seen is kind of the cause of a lot of these like big asset bridge hacks is there's a single contract, which it's called like an omnibus like asset bridge, where there's a single contract that has custody of all of the collateral from every application that has been moved between chains. And it has one security assumption.
Hey, Yorke, you still with us?
Yeah, can you not hear me?
Yeah, sorry. Single contract. There's a single contract, and you cut out right after single contract.
Okay, cool. Sorry. Yeah, so there's a single contract that has custody of all of the collateral that has been moved between chains for any given application. And that contract has a single security assumption for all of those applications. And so it creates this honeypot, right? Where instead of the incentive for an attacker to like take over this system, instead of it being limited to like an individual application's security, it's actually like, you know, the security of whatever the weakest link is of this custody contract, which is securing all of this application value, which is like, you know, hundreds sometimes of different applications, which all have like different user demographics and different networks, basically. And it just doesn't make sense to have to enforce like such a, I guess, universal, like simple security assumption. Like, why not allow applications to isolate their risk from this like omnibus and have application specific security? It seems to make a lot of sense. And I think this is what we see with like applications who have reached a certain scale moving in an app chain direction, right? They want to have more control at that scale over what their security is. They want to isolate themselves from these like counterparty risks that asset bridging today doesn't. And that's why we've seen all these hacks. So sovereign consensus is our solution to kind of that problem we've identified in the market.
Yeah, it allows the application itself to have some control over how their individual security process looks, right? And I think that's actually interesting. It decentralizes the process a little bit, right? And it allows people that have very specific use cases to, you know, add some additional layer. So I think that makes a lot of sense. If we look a little bit more again at the on the receiver side, right? So I was looking through your docs. Like, let's say that I want to implement this on a receiver side. I think I just have to implement the receive interface, right? Is that correct?
Yeah, so that's exactly right. So there's a message recipient interface that you have to implement a single function for. It's called handle, and it's kind of symmetric to what the dispatch interface looks like. So it should be like a super simple developer experience where if the dispatch is destination chain, destination address, and message content, the handler is origin chain, sender address, and message content. So it's like, it's clear what's coming through the pipe. And yeah, it should be like super lightweight to integrate our system. Even so, it's a good call out that you make that basically in order to receive one of these cross-chain messages, you have to implement a specific interface. And the consequence of that is if we enforce that interface, we actually don't get backwards compatibility with like kind of legacy systems for free, in the sense that, you know, all these systems which are deployed today on EVM networks or you know, what have you, don't implement the message recipient interface. And so you can't just do a smart contract call to, you know, OpenSea on OpenSea on Polygon from Ethereum mainnet, or whatever you want to do. You can't just do that without deploying contracts on both sides. And we recognize that that's kind of a high lift for developers to have to deploy contracts on multiple chains, and integrate, or basically implement an interface on both the sending and receiving side. And so as kind of a remedy to that problem, or like developer experience, we've been experimenting with a bunch of new primitives that allow you, or basically like don't require you to implement both sides of the smart contract, like sending and receiving. So we have this concept called interchain accounts. If you're familiar with the Cosmos ecosystem, it's kind of like a concept we borrowed from there, but like fairly different in terms of implementation and interface. But general idea is like, if you constrain the so you'll see in the dispatch and handle interfaces that the message content is just arbitrary bytes. It can be anything.
Hey, Yorke, sorry to call it out again, but you broke up after you said. So actually, this is great because I was going to ask you about interchain accounts next. But you mentioned, why don't you just start again on what an interchain account is?
Cool. Yeah, I don't know what keeps happening. Maybe it's just
it comes at pretty easy times to just say, hey, go back to X. So don't worry about it. It's not too bad.
Okay, cool. Yeah, so interchain accounts are a concept that we borrowed from the Cosmos ecosystem, but that have that we've kind of implemented in a fairly different way and with a different interface. But yeah, if so, you'll notice in the dispatch and handler interfaces that the message content can be arbitrary bytes, and that's the most generalized low-level primitive that we wanted to expose to smart contract developers for basically any possible use case they have, moving between execution environments, etc. Interchain accounts constrain the message content and the message encoding to ABI encoded calls. And what they enable is basically a smart contract on a source chain to have kind of like a proxy identity on a destination chain that can make smart contract function calls on its behalf, and can only make calls which are dispatched from that contract on the source chain. And so it's kind of like a way for a smart contract on any given chain to have atomic composability with contracts on all these other chains, and be able to hold assets and do all these things on other chains without requiring the developer to deploy contracts in all those other environments. So the developer deploys a contract on one chain, which uses the interchain accounts API, and then they can dispatch function calls, like ABI encoded function calls, to contracts on other chains, and those calls will be made from their interchain account, and that allows them to basically like so this is like the perfect application of this is DAOs and cross-chain governance.
I was just about to mention that, right? Yeah, this ability to just pass simple messages on multiple chains like pretty seamlessly seems like a perfect use case for cross-chain governance.
Yeah, so instead of requiring DAOs to like go and deploy a bunch of like adapters on all these chains where they want to do some action from their treasury or whatever, they can use interchain accounts, and they can basically have an account that represents their DAO on all of these other chains and like performs actions on their behalf. And that system leverages the Hyperlane security model, but the developer really doesn't have to operate anything. So like we move from this world where people who are operating DAOs who want to scale to like new chains have to understand like all these new scaling like solutions and execution environments and architectures, like, and has to operate infrastructure to basically like function as a relay or like an oracle between their canonical DAO chain and like their new DAO chain, we move away from that world to a world where DAOs can just like dispatch messages through Hyperlane to these new chains and not have to worry about like operating any infrastructure on those chains, or like even understanding like, the transaction lifecycle or anything of that nature. And it makes the lift for building these cross-chain applications and like performing these cross-chain actions much lighter.
Hey, one second again. So you mentioned the you cut off for 2 seconds again. You mentioned DAOs can. You said DAOs can.
Sorry.
I think you were
yeah.
just basically
DAOs can use the interchain accounts API to do these cross-chain actions without requiring any of the operators of that DAO basically to have any kind of like custom infrastructure or understanding of these new environments, execution lifecycle. Like you don't even necessarily need to understand the transaction lifecycle. So it really lowers the barrier to entry for application developers to take advantage of this like cross-chain functionality. So that's a new developer primitive that we're really excited about. And even beyond that, we just launched what we're calling interchain queries, which similar to the kind of like interchain accounts API, constrains the message encoding to ABI encoded function calls, specifically view calls. And with this API, you can basically make view calls into any remote smart contract state and get the return value as like a callback. And so, we're moving towards a world where developers will have access to basically like async await syntax for querying remote chain smart contract state and like performing actions based on that. So maybe it's like someone wants to do an action which goes and reads a Uniswap v3 exchange rate on Ethereum mainnet, and then on some other network, using the value that it got from that query, does something conditionally. So really, it's just like a much simpler API for people to think about than this kind of like low-level dispatch and handle. And really just like we recognize kind of that the best thing we can do is make the developer experience as kind of simple as possible for us to evangelize this emerging like category of cross-chain architectures. So those are just some of the things we've been working on recently.
I love that. Yeah, you keep pulling things out that I was going to ask you. So I was going to ask you interchain accounts. You pulled interchain accounts out. I was then going to ask you about the queries API, and you pulled that out. What's cool, you actually mentioned this idea of like asynchronous, like very easy async await style operations in this cross-chain world. Rahul, in our very first episode of this show, when we were talking through Connects and some of this cross-chain stuff with him, he said one of the things he was excited about was this idea of like asynchronous solidity that will emerge as a result of all these new innovations. So it's cool you said that. Yeah,
it's just to touch on that super quickly. It's exciting because the modern web is built on like asynchrony, and it just makes sense for us to start to provide those types of tools for developers. I will say that introducing asynchrony does introduce complexity to these like smart contract systems, which must be caution should be taken basically to understand the implications of the introduction of asynchrony to smart contract syntax, because your attack surface area changes a lot. But that being said, I think we can begin to experiment, and you could imagine there being like a transpiler that takes async await syntax and turns it into like Hyperlane interchain query function calls without the developer, like basically with the developer just using that higher level syntax. that's the world we're starting to move towards.
Yeah. Yeah. It's good to highlight safety there, right? Yeah. Async in the JavaScript world typically isn't all that dangerous. It's much more dangerous when there are honeypots of money sitting around. So I'm with you on that one. So one thing that is pretty common in terms of a thread through everything you just talked about is this focus on developer experience. Now, I like your docs a lot, right? I do developer experience work on my day-to-day life at Superfluid, and I thought that you guys have done a pretty good job in introducing like a pretty simple quick start. The interfaces are pretty well done and very simple, right? It seems like you're taking a lot of complex stuff, and this cross-chain stuff is not easy if you want to really break it down to first principles. But for a developer that would want to integrate Hyperlane, I think you guys have done a pretty good job, right? So how do you guys think about developer experience, right? How do you think about these SDKs? How do you think about these APIs? Like, do you guys have a process you're running where you try to like really PM this stuff? Do you guys do interviews with potential developer users? I would just love to understand how you think about it, because it's very clearly something that's consistent across all of what you do.
Definitely, yeah. It's one of my main focuses these days. I think so. We even with the amount of focus that we've given to developer experience, like you said, these concepts are intimidating, and we want to provide abstractions on top of these like security models for developers to use, such that they don't need to understand every single layer of like what's happening in the distributed system, or like the proof of stake economic security, or the fraud proofs. Like, really, developers leveraging these primitives should not be expected to understand all of that. What we've been trying to do to kind of tighten our feedback loop in some of the like experimentation we've been doing is just basically like going to every hackathon we can and providing bounties for developers to use these new primitives. And so I wouldn't say we have a strong process for the ideation. Typically, it's like we kind of identify patterns of what people are asking us is possible with the system on basically like business development calls. We kind of like identify patterns and common threads of what people are doing. So for example, like interchain queries, or these like interchain account systems where you want a nice cross-chain governance primitive. Those are both common threads that we've picked up just in calls with partners, that we then, come up with a design for what the simplest possible API is to abstract away that complexity, and then go out to hackathons and to basically like online bounties platforms, and just try and get people using them as fast as possible. I think that's like one of my biggest frustrations in my career in crypto is like people build these really cool systems that have kind of all these like nice theoretical properties, but they don't get them to market, and they don't like iterate because they don't have people actually giving them feedback, and they don't have tight feedback cycles, and like there's no product feedback. And so it's like so important to just like ship as often as possible, and actually like get stuff into the hands of people, whether it's through like bounties programs or hackathon prizes. I know Superfluid is also kind of a similar mindset, that like that's a great way in this kind of like early and emerging like developer ecosystem to get tighter feedback loops. I think that's been really productive for us. But yeah, I wouldn't say that we have like a super cohesive process around user interviewing. I think it's more like just trying to experiment as much as possible and make sure that we're getting things used kind of early in the life cycle of new features and new kind of like developer primitives.
Yep. Yeah, developer mindshare, man. It's the ultimate resource. We're definitely out there on the hackathon circuit, so we've seen you there.
Yeah, for sure.
So getting into some more like just maybe you personally stuff, I'd love to understand how you think about some smart contract development things, right? So you spent some time, I think you were at Celo and Consensus before Hyperlane, right?
Yeah, that's correct. I did some brief stints at Gauntlet as well as IBM many years ago now. But yeah, I think smart contracts are definitely this like kind of just like intellectually stimulating like engineering stack for me, because it's a whole new set of kind of constraints that doesn't exist in other software environments, or you have to really care about like, low level optimization and having like the utmost security posture where you're doing, you can't ship a single line of code which has a bug, basically, right? And so your entire like development life cycle is completely different from other software fields. But yeah, I mean, I guess, do you want to elaborate on your question? I don't know that I...
Yeah. I'll elaborate. I was just waiting to see if you had anything else to say. What I'd love to understand, and what people want, here's what people want that listen to this show, I think, so far. They like hearing cool technical things. They like hearing explanations of how new protocols work. They like learning about low-level languages and new technologies. And they also love learning how to like actually level up as a Solidity developer, right? And you're someone who's spent, several years, from what I understand, in the space. You've built a lot of like pretty high-impact stuff. What have you done to get better over time? Is it just purely experience? I mean, are there things you do at night or on weekends? I would love to understand just what your process is for improving as a developer.
Yeah, that's a great question. I would love to say that I have like a really precise process for improving all the time, but I think typically it's like more osmosis than any specific process. I think if you spend as much time in the space as I have, I think it's impossible not to just like get exposure to so much. The space moves so fast, and it's really important to kind of like always be eyes and ears up on what the new tooling is that's available. Because like, I think I was describing to you earlier how in the early Consensus days, like I was working on really like prototype level stuff, but the tooling, the smart contract, like developer tooling pipeline at that point in time was like leagues and miles away from where it is today. Like you didn't have these testing for end deployment frameworks that you have today. Like everything was a bespoke system that people like had to build themselves. You had basically like early versions of Truffle that basically had no debugger support, and you couldn't do any of these like more formal methods type stuff that Foundry has been introducing, and some of the like security researchers in the past few years have been like iterating on. You didn't have Open Zeppelin libraries. You didn't have all these teams that have emerged as like kind of just like public goods for the developer ecosystem, which is frankly amazing. And it's just been exciting. Like, I think I've learned to get excited about like tools that can improve just like my efficiency at work, make my life easier. And that's, I think, how I motivate myself to level up, is because it has a tangible impact on my ability to deliver products. And so,
what are some of your favorite design patterns or gas optimizations that you may have implemented somewhere that you'd like to call out?
It's a good question. I briefly touched on the incremental Merkle data structure that we use in the Hyperlane protocol, which is kind of commonly used throughout a lot of smart contract protocols as a library. But what this specifically allows our protocol to do is amortize the cost of signature verification for individual messages. So we can, if we so choose, we can basically verify validator signatures on a single Merkle root, which commits to 10 or 20 unprocessed messages. Do signature verification once against that root, and then provide Merkle proofs to process all of those messages without doing redundant signature verification. So that's like kind of a nice little optimization. I guess there was a fun one in the Celo code base in the our solution to providing on-chain Oracle prices for. So Celo has a system. There's a native stablecoin on the Celo blockchain that it's an algorithmic stablecoin, and there's an on-chain exchange, and we needed to provide Oracle prices to the on-chain exchange for what the price of basically the Celo native asset is denominated in dollars. And you can think of the stablecoin kind of similar to a make or die multi-collateral system, but so we borrowed the concept of using the median of the reported Oracle price from Maker, but with the slight modification that we actually computed the median in constant time as Oracle's report, using kind of like a clever property of the underlying like sorted linked list data structure that we were using. So in the Maker system, in order to compute the median, all of the Oracle prices have to be provided atomically. And then there's like an iteration that happens that verifies that the sequence of prices are basically in the correct appropriate order, and then it just takes the middle element, and that can be fairly heavy to iterate across all of the different Oracle prices, and it also requires that there's some sort of keeper or Oracle who's like collecting all of the Oracle prices, even like, so let's say one of the Maker Oracles goes down. I think that might pose a problem to the Maker protocol, depending on how the implementation works. But at Celo, we had this nice little optimization where as oracles insert to this like sorted linked list that's maintained on chain, so long as they specify the like resultant greater and lesser elements after inserting this new price to the sorted linked list, we can just verify the invariant that the neighbors are correct upon insertion without iterating across the whole list, and kind of maintain a median in constant time, which like doesn't scale with the number of prices being reported by oracles, even in the presence of some failure of a specific oracle feed. So that was definitely a fun one.
All right, final question here. Let's say that we zoom out and we look 10 years in the future at what the crypto industry, let's call it, looks like at that time. What do you hope we've achieved by then, and how do you think our industry is going to evolve over the next decade?
I think my answer is probably that I don't think crypto should be a industry in and of itself. I think we've all kind of got caught up in designing products for what we describe as crypto native audiences. And that mentality to building products, I think, has kind of isolated and siloed our industry off a little bit from the rest of kind of just like emerging tech and the technology sector in general. When really a lot of the technology and infrastructure that we're building within this industry and ecosystem can be put to way better use when applied to problems that are kind of not just like quote unquote crypto native. And so I hope that, I guess, the crypto industry becomes obsolete, and really crypto is just another tool in the tool belt for general software companies building products, and ultimately is just leveraged to provide kind of more trustless experiences or more seamless experiences. I know that's a little bit of a cop-out. I think to be more direct, Sam and I just met in Bogota in the fourth DevCon, and I think the potential for what we're working on to have an impact in emerging markets is, I think, way more apparent after spending time in some of these places than it might be apparently obvious to people who are based in the United States or the EU, who have grown up in economic environments where there's very reliable banking infrastructure and there isn't an absence of currency that you can use as a form of savings. And so, if nothing else, kind of ensuring that some of these just general crypto products like stable coins, and even what Superfluid's building of streaming income in certain assets, I think I would be happy if that started to be used by people outside of Silicon Valley or outside of the United States. That would, I think, make me excited about the future.